Hi everyone, so good morning and we are back into our session. So ये हमारा सेशन फोरियर ट्रांसफॉर्म का सेकंड पार्ट होने वाला है, राइट? सो दिस फोरियर ट्रांसफॉर्म वी आर टॉकिंग अबाउट. सो वी हैव डन फोरियर सीरीज and in the first session we have also talked about Fourier transform introduction part, right? So this is going to be lecture on again the Fourier transform CTFT, you can say part 2. Okay, CTFT part 2 you can say. So continuous time Fourier transform. So let me recall the analysis and synthesis equation. So what was the analysis equation? So analysis equation is nothing but you can say you can find x of omega, right? And we have used this kind of notation. If time domain xt is given, so we can find out the Fourier transform of it, or you can say x of f also. So omega form and f form both I have discussed. Okay. And x of omega is nothing but time x of t raised to power minus j omega t dt. Okay, and integration running from minus infinity to infinity. So this is a integral, Fourier integral, and it's a pair, the inverse Fourier transform we call it. This is nothing but a Fourier transform formal definition, and inverse Fourier transform definition is gonna be, from the spectrum you have to reconstruct the signal back. Okay, so that is nothing but time domain x of t, which is nothing but 1 by 2 pi, okay, integration minus infinity to infinity x of omega e raised to power minus j omega t d omega. And suppose you want to write in terms of f domain, so it becomes x of t equal to 1 by 2 pi will not be present, it is going to be minus infinity to infinity x of f, okay, e raised to power minus j 2 pi f, okay, t d df. So how I'm converting from omega to f? You have to just replace this omega, right? Omega equal to 2 pi f, right? So d omega will become 2 pi df. So this 2 pi and 2 pi gets cancelled, so we don't write that. Okay, so this 1 by 2 pi, this guy will not be present, okay, when we talk about f domain. Okay, so I think this is clear. So this is nothing but a definition, guys, the Fourier transform definition. Okay, Fourier transform definition, please do remember that. और मैंने आपको एफ डोमेन और ओमेगा डोमेन के बारे में बताया था. लेट मी रिकॉल एज वेल एंड देन वी विल कंप्यूट सम ऑफ द फोरियर ट्रांसफॉर्म्स. Like we have got we will be given a time domain signal and we have to compute the Fourier transform. So some useful Fourier transform pairs, right? Some useful Fourier transform, okay, pairs that you have to remember as well, okay, because in the exam you don't have much time to compute the Fourier transform directly. So you can remember. So suppose suppose delta t is there. So what is the Fourier transform of delta t? The Fourier transform of delta t is nothing but 1. Okay, in you can say that x in f domain and x omega domain, so it is 1 also. Second one is nothing but, suppose you have got a rectangular pulse rect, okay, rect t. So rect t has a Fourier transform sinc f. Okay, always remember rectangular has the Fourier transform sinc f. Rectangular has the Fourier transform sinc f. And if you want to convert into omega domain, like omega form, so you can replace this f by so f is replaced by omega by 2 pi, right? So you can say that this is going to be sinc of omega by 2 pi, right? Because many students have a lot of confusion in switching from f form to omega form, right? So do remember, I have told you one technique. If in the Fourier transform there is no impulse present, so you can simply replace f by omega by 2 pi or omega equal to 2 pi f. Okay. Third is suppose we have got triangular function, triangular t, right? So triangular t is nothing but sinc square f, okay, Fourier transform, and in omega form sinc square omega by 2 pi. So rectangular has got the Fourier transform sinc and triangular has got the Fourier transform sinc square. Okay. And the fourth standard one is nothing but you can say sinc one. So sinc of t, right? So sinc of t has a Fourier transform rect, okay, rect of f, okay, or you can say that rect of omega by 2 pi, okay. So rect of omega by 2 pi is going to be the omega form, okay. Now if I talk about see, these are the Fourier transform where no impulses are present, right? ठीक है, कोई भी impulse present नहीं है, but there are trigonometric functions like cosine, ठीक है. मान लो आपके पास cosine 2 pi alpha t है, right? 2 pi alpha t. What is the Fourier transform of this? It has the Fourier transform in f domain I am talking about. See, f domain, it will be nothing but 1 by 2 delta f minus, f minus, okay. Now what is f here? F is going to be alpha only, right? You can forget about 2 pi, so it is nothing but f minus alpha plus delta f plus alpha. Okay, now we want to convert into omega form. This is in f form, okay, f form. Now we want to convert into omega form. So as you can see here, the Fourier transform of this cosine 2 pi alpha t has got the impulse, okay. If it has got the impulse, so you have to replace, you have to replace delta by 2 pi times delta omega, okay. That is very important, okay. So delta f has to replace by what? 2 pi times delta omega, ठीक है. सो इसको आप 2 पाई से मल्टीप्लाई करवाएंगे तो ये हो जाएगा 2 2 कैंसिल, सो पाई delta omega. Now this alpha has to be also changed to omega because this is just a hertz, so you can say this is nothing but 2 pi alpha plus delta omega plus 2 pi alpha, done. So this is in omega domain, omega form, not domain, you can say omega form, right? So now we will talk about sine, okay. So sine 2 pi alpha t, sine 2 pi alpha t in f form, that is nothing but 1 by 2j, right? 1 by 2j, delta, right? So delta, you can say that f plus alpha, okay, that you have to remember, f plus alpha minus delta f minus alpha, okay. Now you have to convert into omega form. So this is given in f form. Now you have to find in omega form, right? So in omega form कैसे लिखेंगे? Just you multiply 2 pi, so it is nothing but pi upon j, right? Delta omega minus omega plus 2 pi alpha minus delta omega minus 2 pi alpha, okay. So this is an omega form, fine. So I hope this makes sense. So now the confusion between the f form and the omega form should not be there, okay. Let's talk about other Fourier transforms. So suppose we have got any exponential like e raised to power minus alpha t ut. What is the Fourier transform? The Fourier transform, it has the Fourier transform 1 upon alpha plus j 2 pi, 2 pi alpha 2 pi f, okay, understood. So 2 pi f, okay. Now in, or you can say that in omega domain it will be alpha plus j omega, okay, alpha plus j omega. Please do remember this Fourier transform, right? Suppose you have got e raised to power minus 2t ut. What is the Fourier transform? So Fourier transform is nothing but 2 plus j omega. This minus 2 has, okay, please remember this. Now if you multiply t, okay, t times e raised to power minus alpha t ut, okay. So there is a property, I will discuss the Fourier transform property, but you should remember, okay. So t times e raised to power minus alpha t ut has the Fourier transform 1 upon alpha plus j 2 pi f ka whole square, okay. Or you can say that, 1 by alpha plus j omega ka whole square. Since we are changing, in this Fourier transform there is no impulse, so simply we can replace this 2 pi f by omega, right? That's it. Next is suppose you have got two-sided exponential, ये आ गया, right? और ये हमेशा इवन होता है, ऑलवेज इवन का है, right? सो मॉड जैसे आ गया ऑलवेज इवन, ई रेज टू माइनस अल्फा मॉड ऑफ टी, so it has the Fourier transform, remember 2 times this alpha, ठीक है, this alpha upon alpha square plus you know 2 pi f square, मतलब you can say 4 pi square f square, ठीक है, 2 pi f square or you can say 4 pi square f square. Now what you can do here is you can write this as 2 alpha upon alpha square plus omega square. So I think remembering this is far easier compared to f form, right? So you can remember, मतलब आप कुछ भी कर सकते हो, है ना? Okay, so hopefully this makes sense. एक बहुत ही powerful Fourier transform pair है, that is called as Gaussian pulse. So e raised to minus pi t square, ठीक है, pi t square. What the Fourier transform of this is nothing but e raised to minus pi f square in f domain. Now since there is no you can say impulse, so you can replace it by f can be replaced by omega by 2 pi, so it is nothing but e raised to power minus pi square will be getting cancelled, so f omega square by 4 pi, ठीक है, ये Fourier transform आएगा, right, in omega form we can say, right? Now let us talk about signum. Okay, signum of t. So signum of t has a Fourier transform 1 by j pi f, right, 1 by j pi f. Okay, now if you want to convert into omega form, so it is nothing but 2 by j omega, you can write like this, okay? Both are same only, provided omega equal to 2 pi f or f equal to omega by 2 pi. Okay, you should be able to substitute this and find out. And why we are able to directly substitute this, because there is no impulse present in the Fourier transform. Okay, pair. ये टेक्निक आपको नहीं पता चलती है, and everybody has lot of confusion, right? So if you know, so what is my suggestion basically is, my suggestion is you have to consistent with one form, right? Whether it is okay, please do remember that, understand, huh? So I think this is clear, yeah. Now if I recall ut, what is the Fourier transform of ut? The Fourier transform of ut means unit step, right? So ut, okay. So ut has the Fourier transform, what is that in f domain if I say, right? So ut has the Fourier transform 1 by 2 delta f, okay, 1 by 2 delta f plus 1 by j 2 pi f, right, in f domain. Now in omega form you can say that, so f को replace करना है omega by delta f has to replace by 2 pi delta omega, so it is nothing but pi delta omega plus इसको replace करना है 1 by j omega 2 okay 1 by j omega only, sorry. So अगर आपको याद रखना है तो आप ओमेगा फॉर्म में याद रखिए, ut has a Fourier transform 1 by j omega, okay, plus pi delta omega, ठीक है, क्योंकि what we are doing is we are replacing this delta f by 2 pi delta omega, simple, since there is a impulse present, okay, understand. So if I talk about cosine, suppose exponential is multiplied with the cosine like this, e raised to power minus alpha t cosine 2 pi beta t ut, ठीक है. So there is a property, find out the Fourier transform of this guy and then shift by some some alpha, right? Okay, so these are the property basically, so we'll see that, ठीक है. So इसका हो जाएगा Fourier transform alpha plus j 2 pi f, okay, alpha plus j 2 pi f in f domain upon alpha plus j 2 pi f whole square, ठीक है, whole square plus 2 pi beta का whole square. You see here whatever in the numerator same you have to write in the denominator and take the square plus 2 pi beta. Now if you want to write in omega domain, so you can replace, since there is no impulse, right? So you can write alpha plus j omega upon alpha plus j omega ka whole square, right, plus, you know, 2 pi beta, right, 2 pi beta. So 2 pi beta you have to keep as it is. Okay, 2 pi beta as it is you can write. Okay, there is no change. So hopefully this makes sense and you will be able to write it. Okay, so जैसा मैं लिख रहा हूँ वैसा आप लोग लिखो बार बार. Okay, and you have to practice because in the gate examination you don't have time, right, to, you know, formulate all these things. अगर आपको ये playlist, I mean ये list पता है, not playlist, ये list पता है, then your life becomes more easy. ठीक है. जैसे एक होता है impulse train. Suppose you have got impulse train of this kind, right? You know, so suppose you have got the impulse train delta t minus nt, and where, you know, where this capital n goes from minus infinity to infinity, right? So it is nothing but kind of periodic signal, right? It is nothing but a periodic signal, and it is a impulse train. ठीक है, तो ये आपका क्या है? Periodic signal है, periodic signal, and it is nothing but the impulse train, right? It is the impulse train, right? So first of all, you know, if it is a periodic signal, so you have to find what the Fourier series. Fourier series का क्या हो जाएगा? Fourier series gonna be 1 by t simply, right? That everybody knows. Okay, so it has the Fourier series 1 by t, that is ck, and exponential का Fourier series होता है delta only. Exponential will be there, na, right? So I will prove these things, okay, later, but just remember that कि this is going to be written as n equal to minus infinity to infinity. This 1 by t factor will be coming out, please remember. Okay, when you are finding the Fourier transform of this, I'm talking about Fourier transform, right? So 1 by t is because of Fourier series, right? Now you can write this delta, you know, f minus, okay, f minus k by t, where k is going from minus infinity to infinity. You can see this k you can take, right? So impulse train has the Fourier transform impulse train only, okay, but this factor will come out, right? Okay, all the amplitude are going to be scaled by 1 by t. Please do remember that. ये भी impulse train ही है, ठीक है? तो कैसे याद रखेंगे? देखो, n equal to minus infinity to infinity delta t minus n capital T, where capital T is nothing but the fundamental period, has the Fourier transform 1 by t summation k equal to minus infinity to infinity delta f minus k by you know k by t, right? K by t, yeah. Now if you want to convert into omega, right, so what you have to do here is you have to multiply, you have to replace this delta by 2 pi delta omega. So 2 pi आ जाएगा यहाँ पर. So 2 pi by t summation k equal to minus infinity to infinity. अब आपको लॉजिक पता चल गया कि if the Fourier transform has got impulse, so we have to introduce 2 pi, right? 2 pi by t, and now this can be written as omega minus, now this you know, k by 2 pi. So this is nothing but 1 by t, which is having the dimension hertz f. Now you want to write 1 by t, which is omega. So now you have to introduce what? The omega is nothing but 2 pi by t, right? So you can say that this is 2 pi k by t. बस खत्म, ठीक है? So I think it's very simple, provided you have attended धीरज sir class, right? So ये चीज़ मुझे भी समझ नहीं आती थी पहले, but now confidently I can write and you guys can write also, ठीक है? कि you know how we are moving from f form to omega form, right? Many people have lot of confusion, but तो याद रखना impulse train का Fourier transform impulse train ही होता है, right? ठीक है? Impulse train Fourier transform impulse train only, ठीक है? तो if you have got any periodic signal, so first of all you have to find the Fourier series and then you have to find the Fourier transform, okay? Because that why Fourier series? Because you need to find the Fourier series coefficient corresponding to that periodic signal, okay? we'll see how to find the Fourier transform of periodic signal. So Fourier transform is meant for, you know, the non-periodic signal. Okay, if the signal is non-periodic, then we go for Fourier transform. But as if the signal is periodic, so if we can still find out the Fourier transform. Okay, जैसे देखो, suppose we have got the definition here, a definition of Fourier transform. Okay, what is the definition of Fourier series? Sorry, definition of Fourier series, or you can say synthesis equation, xpt equal to ck e raised to power j, you know, you can say 2 pi k f naught t, right? And where k is going from minus infinity to infinity. This is nothing but your, or you can also write this as k equal to minus infinity to infinity ck e raised to power j omega k omega naught t. Okay, because 2 pi f naught can be written as, okay, omega naught is nothing but 2 pi f naught. ठीक है, सो अब देखो यार, इसका फोरियर ट्रांसफॉर्म निकालना है, राइट? इसका फोरियर ट्रांसफॉर्म, व्हाट इज द फोरियर ट्रांसफॉर्म ऑफ दिस गाय, राइट? व्हाट इज द फोरियर ट्रांसफॉर्म ऑफ दिस गाय, since it is a periodic guy, right? Given signal is a periodic signal. Okay, so you know, you have to understand, this is amazing, okay, part of it. Okay, so if you know the property, you can write the Fourier transform right away. But since there is an exponential, you know, remember in the time domain, if there is an exponential, in the frequency domain there will be impulse. ठीक है, अगर टाइम डोमेन में कोसाइन है, साइन है, you know, impulse है, sorry, this you can say that exponential है, time domain में multiplied है, then there will be impulse in the frequency domain, right? So this can be written as, याद रखना, k is going from minus infinity to infinity ck, ये तो कांस्टेंट है, सिंपल है, ck e raised to power j k omega naught t has the Fourier transform, or you can say that this omega naught is nothing but 2 pi f naught. So you can write this as, I'm writing in f form first, so summation is gonna be staying there, ck will also be there. Now what is the Fourier transform of this guy? Using the property, you can directly write it. Okay, delta f minus, you know, you have to write k f naught, right? delta f minus k f naught. ठीक है, अगर आप इसको ओमेगा में लिखते हैं, so you know, you have to introduce 2 pi now, so it is nothing but k, okay, this is 2 pi ck delta omega minus, you know, k omega naught, right? 2 pi से मल्टीप्लाई करना मतलब k omega naught. Life is very simple, right? Now you see the Fourier series and the Fourier transform, the difference, right? In case of Fourier series, we find out the coefficient and we write the trigonometric Fourier series or kind of thing, where cosine and sines are present. Here we are taking the Fourier transform, so we are getting the impulse. Okay? So I think converting from here to here is no problem, and you should not also get confused, you know, by these things. Okay? In fact, I don't find confusion, so I'll discuss many properties right away only. ठीक है, तो देखो मैं कुछ properties भी जल्दी से बता देता हूँ, right? So there are some operational properties of the Fourier transform. We call it operational properties of the Fourier transform. Operational properties of Fourier transform. What are these operational properties of the Fourier transform? So, you know, there are, like we call it, there are many properties. Okay, so linearity property means, suppose, okay, let me recall linearity property. Okay, kind of linearity. What is linearity property? Suppose you have got x1t has the Fourier transform, you know, x1 omega, x2t has the Fourier transform x2 omega. So you can multiply by any scalar constant, so alpha times x1t. Suppose combination is given and you have to find the Fourier transform, so you can find the individual Fourier transform, right? So alpha times x1t plus beta times x2t has the Fourier transform alpha times x1 omega plus beta times x2 omega. It's a very simple thing that I can tell. And next is time scaling property. Time scaling property, right? So we'll prove one by one. Just I'm listing down all these things, okay, as a matter of completeness. ठीक है, तो आपको बस एक बार देख लेना है ये क्या है, ठीक है। तो मान लो तुम्हारे पास टाइम स्केलिंग का मतलब क्या है। सपोज यू हैव गॉट एक्स टी का फोरियर ट्रांसफॉर्म एक्स ऑफ ओमेगा और यू कैन से एक्स ऑफ एफ। now please don't get confused between f and omega, okay, it's a very simple. So xt, if I write xt x alpha t, what is the Fourier transform of this x alpha t? So this alpha has to be divided, okay, and it will be f by alpha, okay, this has to be written by f by alpha, ठीक है। और इन फ्रीक्वेंसी डोमेन क्या हो जाएगा, सो इट इज नथिंग बट 1 by alpha x of omega by alpha, ठीक है। इट्स अ वेरी सिंपल प्रोसीजर, ठीक है। सो प्लीज डू रिमेंबर दैट f डोमेन का ये है और सिंपली ओमेगा डोमेन का ये है, ठीक है। in general it is in general signal, okay। and if I talk about folding, right, so तीसरा हो जाएगा folding or time reversal also we call it time reversal, time reversal. So suppose we have got xt as xt का Fourier transform x of f or you can say x of omega. So x of minus t has the Fourier transform x of minus f only, right? Suppose there is a minus t, so you can also replace in frequency domain, in a spectrum you can replace f by minus f, right? Okay. And also you can write this as x of minus omega, okay. I hope this makes sense. Okay, so we'll prove one by one, okay. And there is a time shift property, right? Time shift. Time shift का मतलब क्या होता है? Remember this, okay. Time shift means suppose you are shifting, okay, in the time domain, like you can say suppose xt has the Fourier transform, x of f or x of omega. Remember, time shift in the time domain correspond to phase shift in the frequency domain, right? So time shift matlab phase shift, and phase has to be written in terms of exponential, right? So if you are shifting in the time domain, so in the frequency domain there will be exponential term, okay, multiplied, okay. So x of t minus alpha, the Fourier transform is nothing but, see, the Fourier transform is going to be x of f only, but e raised to power minus j 2 pi f, and this alpha will be here, or you can write this as x of omega e raised to power j alpha omega, ठीक है, j omega alpha or whatever you wanna write, ठीक है। और मान लो x of t plus alpha होता, so it has the Fourier transform, okay, let me write in next page so that, और LCC में लिख देता हूँ, कोई दिक्कत नहीं है। अगर हम प्लस लेते हैं, राइट, सो यू कैन से दैट एक्स टी प्लस अल्फा हैज द Fourier transform x of f e raised to power j plus j now, okay। अगर यहाँ प्लस है टाइम शिफ्टिंग में, यहाँ प्लस है तो यहाँ प्लस, माइनस यहाँ है तो माइनस यहाँ, ठीक है। सो दिस इज 2 पाई f alpha, or you can write this as x of omega e raised to power j omega alpha. It's a very simple, okay. Now we will talk about frequency shift, right? So how to get the frequency shift? देखो frequency shift means we can write frequency shift, okay. frequency shift. How to get the frequency shift? Like, you know, what you have to do in the time domain so that you can get some shift in the frequency domain. So you have to multiply by exponential. Okay. So e raised to power j 2 pi alpha t x t अगर आप multiply करते हैं time domain में, so it will give you the shift. Okay, that the Fourier transform f minus. Okay, see this is plus, so here the minus will be there. Okay, and this f has to be subtracted, that is alpha. Okay, if you are in alpha domain, and if you are omega form you would want to write, so it is nothing but 2 pi alpha khatam. Okay, so minus will be there, and e raised to power minus j 2 pi alpha t xt agar hai, so this will give you the Fourier transform. Remember, xt has the Fourier transform x of f or x of omega. Okay, so here it will be nothing but f plus alpha. ठीक है, देखो अगर exponential multiply the time domain में, so Fourier transform of this guy you have to find and shift by this or shift by this. Okay, depending upon the f form or omega form. Okay, ठीक है, that you have to do next. So this is one of the important fact, right? So please do remember that. ठीक है, frequency shift, time shift, phase shift, frequency shift. Now we'll talk about convolution of two time domain signal, right? So convolution property. So suppose you have got xt convolve, you know, by t. So as I said in the during convolution discussion, so convolution in one domain correspond to multiplication in another domain. So it is x of f and by of f, or you can say that x of omega by of omega. Okay, this is one of the important fact, please do remember. Okay, now multiplication, right? So if you are going to multiply in the time domain, multiplication in the time domain means xt times, you can say, ht has got the Fourier transform, right? Multiplication in one domain correspond to convolution in another domain, so x of f times h of f, or 1 by 2 pi, right, x of omega times h of omega. So if you are convolving, right, this is convolution, right? Please do remember convolution. So in omega form 1 by 2 pi has to be added here, introduced. Okay, but in f domain no 1 by 2 pi will be there. Okay, so multiplication correspond to convolution in another domain. Okay, now we will talk about modulation. Okay, this is one of the important property okay, which will lead to communication system as well, right? So modulation is one of the important phenomena, right? Modulation is one of the important operation, you can say. So if you multiply any signal xt is there, if you multiply by cosine 2 pi, you know, 2 pi alpha t, you can say, right? So if you are multiplying cosine or sine, and cosine or sine considered to be having highest frequency, right? They have very high frequency. Okay, so if something is multiplied xt, here we can consider as a massive signal also. So xt is a time domain signal multiplied with the cosine. Okay, so you know, if you are multiplying cosine with the xt, right, so here you can use the multiplication property. So multiplication in one domain correspond to convolution in another domain. Okay, so it has the Fourier transform. Okay, it has the Fourier transform of this kind. So you know, 1 by 2 x of f plus alpha minus plus x of f minus alpha. Okay, that delta and the x of f will be convolved, right? So you will get this, or what you can do here is you can introduce you can write this in terms of what? You can write this 1 by 2 x of omega plus 2 pi alpha plus x of omega minus 2 pi alpha. Okay, so this 1 by 2 will be present, that's it. Okay, in both the case. This is modulation. Fine, now we'll talk about differentiation. Suppose you differentiate, or derivative we call it, differentiation. Suppose you have got signal xt, what is the Fourier transform of this? That is x of omega. Suppose you're differentiating this x dash t. What is the Fourier transform of this? Differentiation in time domain means you have to multiply by 2 pi, j 2 pi f x of f, or you can say j omega times x of omega. Okay. Okay, so I'll talk about separately. I mean, we'll prove all these property, but please do remember this. Okay. Okay. So if you are going to multiply by time, okay, t in the time domain signal. Okay, so multiplication by t in time domain. What does this lead to? You can say. Okay. So if you're multiplying by t in the time domain, right? So remember this, suppose you have got x of t, so it has the Fourier transform x of f or x of omega. Suppose you are multiplying j 2 pi t xt, okay, minus j 2 pi t xt, so it has the Fourier transform, okay, differentiation in frequency domain, we call it. What we call it? This is nothing but multiplication by t in the time domain correspond to differentiation in frequency domain. Okay, frequency domain differentiation property. ठीक है, so minus j 2 pi t, okay, minus j 2 pi t xt equal to x dash f, or you can write this as 2 pi x dash omega. ठीक है, so minus t xt is equal to x dash omega. This is the very important result, please do remember that. Okay, again let me write x minus j 2 pi t xt in the f domain, that is x dash f, in the frequency omega form, that is nothing but 2 pi, so that 2 pi gets cancelled, so minus jt xt as the Fourier transform x of omega. ठीक है. Okay, so this is one of the important fact. Now there is an integration property. Okay, integration property. Integration property. So integration property is very important because many question has been asked from this property. ठीक है. तो आपको फोरियर ट्रांसफॉर्म में पढ़ना क्या क्या है? First of all, you should know analysis equation, synthesis equation, and then you should know the properties. If you know the property, you can play with the Fourier transform. I will solve many questions, don't worry. So मान लो जैसे तुम्हारे पास दिया है माइनस इन्फिनिटी टू टी एक्स ऑफ टी डी टी. What is the Fourier transform this? So Fourier transform this is going to be, आपको ये पता होना चाहिए what is this. ठीक है, देखो बाय डेफिनेशन अगर आप याद करो, so x of t dt, what is this? This is nothing but you can say that x of t convolve ut. Okay, so convolution in one domain correspond to multiplication in another domain, right? So इसका Fourier transform क्या हो जाएगा सर? इसका Fourier transform in f domain I am talking about, right? So that is going to be 1 by j 2 pi f, okay, 1 by j 2 pi f x of f plus, okay, 1 by 2 x of 0, okay, and delta of f. So what I will suggest here is, guys, remember everything in the omega domain, that is EG, right? ठीक है, देखो ये कितना डिफिकल्ट लग रहा है, ठीक है, बट अगर हम ओमेगा डोमेन की बात करें तो ओमेगा डोमेन में देखना कितना इजी आ जाएगा. ठीक है, सो 2 पाई दिस इज ओके, सो पाई एक्स 0 डेल्टा ओमेगा प्लस एक्स ऑफ ओमेगा बाई जे ओमेगा. ये तो बहुत सिंपल है. ठीक है, कैसे देखो कैसे याद रखेंगे. तो माइनस इन्फिनिटी टू टी x of t dt का फोरियर ट्रांसफॉर्म पाई एक्स जीरो डेल्टा ओमेगा प्लस एक्स ऑफ ओमेगा बाई जी ओमेगा। अब इसको आप कन्वर्ट कर सकते हो किसमें, यू कैन कन्वर्ट इनटू यू नो एफ फॉर्म, नो प्रॉब्लम विल बी देयर, ठीक है। And if I talk about conjugation property, right? So if you conjugate time domain signal, right? Conjugation, right? Conjugation property. Suppose you are conjugating x conjugation t. So suppose xt has the Fourier transform x of omega, right? So x conjugation of t will be having what? तो अगर आप टाइम डोमेन में कॉन्जुगेट कर रहे हैं, राइट, एंड इफ इट इज रियल, okay, nothing is gonna happen over there. But in case of x in, आपको कैसा करना है, you have to conjugate your frequency, बट यहाँ माइनस एफ लिखना है क्योंकि कॉन्जुगेट करोगे तो प्लस हो जाएगा, तो माइनस एफ हैज टू बी देयर। और इसको आप कैसे लिख सकते हो ओमेगा फॉर्म में, दैट इज नथिंग बट एक्स ऑफ conjugation minus omega. So conjugation in time domain, conjugation in frequency domain as well, provided replace f by minus f. Okay, fine. So there is a more important property like correlation and autocorrelation. So correlation property, correlation in time domain. Suppose x of t, okay, these are the two stars, means correlation by t. So what is the Fourier, what is the property here? So you can just find the Fourier transform of xt, then take the conjugate of that x of f, multiply this, ठीक है, in omega form, ये कोरिलेशन के केस में हो जाएगा, ठीक है। एंड ऑटो कोरिलेशन में क्या रहेगा, ऑटो कोरिलेशन ये इंपॉर्टेंट है फॉर कम्युनिकेशन सिस्टम, ऑटो कोरिलेशन एंड ऑल, राइट। सो यू शुड नो द Fourier transform of autocorrelation, right? So that is nothing but spectral density you will get, okay. Fourier transform of autocorrelation is gonna be spectral density. So x of t का correlation x of t के साथ, right, that is going to give us x of f times conjugate of x of f, or you can also write this as x of f का whole square, or x of omega conjugate करके, and then you can write this as x of omega का square. So इसको हम लोग डेंसिटी भी बोलते हैं, पावर डेंसिटी और एनर्जी डेंसिटी, ओके, डिपेंडेंट अपॉन द सिचुएशन, ठीक है। So I think these are the properties that you have to remember, and there are some Fourier transform theorems which are very important और question directly आ जाते हैं, ठीक है। Fourier transforms theorems, इनका सबका यूज आपको करना है इन द प्रॉब्लम. सो इफ प्रॉब्लम इज गिवन यू हैव टू गो थ्रू द प्रॉब्लम एंड देन so we'll start taking examples and then so many things. So there are Fourier transform theorem. So suppose you are finding the time domain. Okay, suppose you are in time domain, right? Spectrum is given. Okay, remember, so first theorem is what? Given spectrum का मतलब क्या है? X of f is given, or you can say x of omega, right? Finding you can say x of t at t equal to 0. ये क्वेश्चन आ सकता है. The Fourier transform is given, you have to find x of t at t equal to 0. So what you can recall here is, you can say that xt equal to minus infinity to infinity x of f e raised to power plus j 2 pi f t dt. Now if you plug t equal to 0 here, so या कि आप ऐसा लिख सकते हो कि this is nothing but x of 0. Okay, so it is what? Minus infinity to infinity x of f df. Okay, this is df only. What is this, guys? This is nothing but area under the spectrum. Area under the spectrum. Okay. So finding the value at t equal to 0 in the time domain, if a spectrum is given, means you have to calculate the area under the spectrum. Okay, this is the first theorem that you can understand. Okay, ये f डोमेन में है. अगर मान लो फ्रीक्वेंसी उसमें ओमेगा डोमेन में दिया है स्पेक्ट्रम, राइट? सो गिवन x of omega, so your x of t at t equal to 0 is going to be 1 by 2 pi minus infinity to infinity x of omega d omega. ठीक है. So both forms आपको याद रखना है. If you are in omega form, so 1 by 2 pi has to be multiplied as well. ठीक है. तो एग्जाम में क्या पूछा जा रहा है आपको समझना है. ठीक है. मान लो आपसे पूछा जाता है कि what is minus infinity to infinity x of omega d omega. So what they are asking? They are asking area under the spectrum, right? So it will be equal to 2 pi x of t at t equal to 0. ठीक है. Okay, so this is one of the important fact, please do remember that. Okay, and suppose time domain spectrum is given, right? Like, sorry, time domain is given. Suppose xt is given and they are asking finding spectrum at omega equal to 0, or you can say x of f equal to 0. So x of 0 is going to be minus infinity to infinity area under the time domain signal. Direct. You can prove also. Take the definition and prove it. So this is one theorem. We call it central ordinates. इनको हम लोग क्या बोलते हैं? These are called as central ordinates. Central ordinates. These are known as central ordinates. Okay. Okay. What is the meaning of this? Looking spectrum at origin, at 0 or origin, you can say. Okay. Now there is a theorem called Parseval theorems. Parseval's theorems. You know that now we are dealing with energy signals. Okay, we are not dealing with we are dealing with aperiodic signals, right? And we are trying to find the Fourier transform of aperiodic signal. Okay, so we are dealing with energy signals. We are not dealing with the power signals. Okay, so the energy in the time domain will be equal to, so you can also suppose spectrum is given, x of t has a Fourier transform x of omega or x of f. So energy in the time domain कैसे compute करते हैं? Modulus x of t square dt will be equal to minus infinity to infinity x of f square df, और in omega form क्या हो जाएगा? So in omega form always remember 1 by 2 pi से multiply करवाना पड़ेगा. ठीक है. d omega. Since this d omega we are writing, so 1 by 2 pi has to be written here. ठीक है. So that both are same. So energy you can compute in the time domain, but if you know the spectrum, you can also find the energy in the. So this is what energy. Energy is being related. Okay. Energy is being related, and there is one more theorem. We call it Plancherel's theorem. Okay. Plancherel's. Okay. Plancherel's theorem. ये बहुत important theorem है. Plancherel's. Okay. Parseval theorem. Okay, suppose xt and yt both are different. Here xt was same, right? That is why we use okay, we square it and find out the energy. But suppose xt is given, yt is given. Okay, and they are asking you to compute this x of t times y conjugate of t dt. So what is this? In frequency domain, you can write this as x of f y conjugate of f df, right? Now you have to understand that. Okay, so in ओमेगा डोमेन क्या लिख दोगे, 1/2 पाई यहाँ लिखना पड़ेगा, माइनस इन्फिनिटी टू इन्फिनिटी एक्स ऑफ ओमेगा बाई ऑफ ओमेगा डी ओमेगा. ठीक है, hopefully this makes sense to all. Fine. So this is how you have to do it. Okay, and your life will be simple. So these are the theorems that you have to remember, right? So you have to use one form consistently, okay, so that you should not get confused. Okay, and Fourier transform is a linear operation and that always obeys superposition that we have already discussed. Okay, so we'll try to find the Fourier transform pair, okay, of some of the signals I have listed down, है ना. लेकिन अब हम लोग क्या करेंगे, वी विल ट्राई टू कंप्यूट देम एज वेल. ठीक है, एक एक करके हम लोग करेंगे. सो प्रॉपर्टी मैंने बता दी, सारा बता दिया. ठीक है, यस. एंड देयर इज वन वेरी इंपॉर्टेंट प्रॉपर्टी दैट आई थिंक आई डिड नॉट डिस्कस. उसको बोलते हैं डुअलिटी प्रॉपर्टी. उसको भी बता देता हूँ. डुअलिटी प्रॉपर्टी, डुअलिटी, or we call it similarity property also. Similarity property, right? So duality property क्या होता है, मान लो तुम्हारे पास suppose xt has the Fourier transform x of f or x of omega. So suppose x of t is given, right? Suppose you know the spectrum, but in place of omega they have replaced by t. xt is given, capital xt. Okay, so its Fourier transform is going to be small x of, simply you have to replace that time domain by minus f, t by minus f, or 2 pi x of minus omega. ये duality property है. okay? It's a very simple situation that we can remember. बहुत easy है. Okay, so I think I'll take questions in the next session only, right? Okay, and we will verify everything. Yeah, we'll verify everything whatever we have discussed, and I think tomorrow next session is going to be the last session. Okay, and we'll move to next chapter. Okay, thank you. So now using these concepts you can start solving the questions, and let me know if you are facing any problem, right? So please watch the session carefully. जो भी मैंने लिखा है अब question करेंगे, we will use these properties, useful relations, okay.